So in this section, we will talk about derivatives of exponential functions as well as inverse trig functions. And in this case here, we're talking about the exponential function rule, meaning we have 2 to the x, 5 to the x. So b is any base, and this derivative is this function b to the x times the natural log of that base, which in this case is b. And this base e exponential rule follows the same rule, meaning this would be e to the x times the natural log of e, because e is your base, but remember the natural log of e is 1. So really what it looks like is this, but this right here simplifies to 1. Okay, so we don't write that. All right, then we have 6 additional inverse trig function derivatives, and you must commit these to memory. The derivative of the inverse of sine is 1 over the square root of 1 minus x squared. The cofunction, cosine, for sine, the only difference is now this will be negative. So it is negative 1 over the square root of 1 minus x squared. Okay, then you have the inverse tangent, which will be 1 over 1 plus x squared. And then the cotangent, remember c's are negative derivatives, 1 over 1 plus x squared. Secant is 1 over x times the square root of x squared minus 1. And then the cosecant will be the same except for negative. Okay, so these are some hints that I went over when we were talking about derivatives of trig functions. Remember, trig functions that begin with c are negative, meaning their derivatives are negative, like these right here. And then cofunctions that are complementary, which was reviewed in trig functions, meaning cosine is the complementary trig function of sine, cotangent of tangent, and cosecant of secant. They will have similar derivatives if you didn't notice here. The most common ones that you will see are these 4, not to say that you will never see secant and cosecant, but these 4 are the most common that you would see.